Have you ever seen an election poll and just thought, no way, that's impossible? I mean, how can a handful of people possibly predict what an entire country is going to do? It feels like some kind of magic trick or maybe, a bit of a scam. Well, today, we're going to pull back that curtain. We're going to find out the secret.
Right? This is the question that trips everybody up. 1,000 people to predict 100 million. The scale just feels completely off. Your brain is probably screaming that you can't learn anything real from a sample that tiny. So is it all just a wild guess? Or is there something deeper, something statistical going on here?
So let's just dive right in and tackle this feeling head on. Because that little voice of doubt in your head, it's actually pointing us toward a really interesting statistical puzzle. And let's be honest, that feeling is totally logical. I mean, if you just went out and grabbed 1,000 people at random, you'd expect her opinions to be all over the map. It would feel like pure dumb luck if they just happened to perfectly reflect an entire country. So yeah, you're right to be skeptical. But here's the twist. And this is the heart of it all. Our gut tells us it's a shot in the dark. But what statisticians figured out is that a truly random sample, well, it isn't just a guess. It's a guess that actually follows very specific, predictable rules. And that predictability, that's the secret we're about to unlock. Before we get to that big secret, though, we gotta face the biggest problem with sampling head on. See, the thing is, if you take one sample and then you take another one, you can get completely different answers. Let me show you what I mean. Okay. So let's imagine the entire voting population is this giant barrel filled with millions and millions of marbles. Red for candidate A, blue for candidate B. We reach in and take our first random scoop of, say, 1,000 marbles. And in this scoop, looks like candidate B is winning, 52-48. Now, we put that scoop back, we shake up the barrel, and we take another scoop, another 1,000 marbles. And whoa, hold on. This time, candidate A is ahead, 54-46. That's a totally different result from the first one. All right, let's do it one more time just to be sure. Third scoop. And now it's basically a dead heat, 51-49. The point is, every single time we dip into that barrel, every time we take a sample, we get a slightly different picture of reality.
And this leads us to the big problem, right? If every single sample tells a different story, how can we possibly trust any of them? Which one is the real one? Which scoop actually reflects the true mix of red and blue marbles in the whole barrel? It kind of feels like we're right back where we started, just guessing. But we're not.
Here's the twist. What if all that variation, all those different answers, what if that isn't a flaw in the system? What if it's actually the key to understanding everything? It turns out this is where statisticians pull out their secret weapon. And that weapon is called a sampling distribution. I know, sampling distribution sounds super technical, right? But forget the name for a second. Just think of it like this. It's a map of every possible result you could ever get from all those different scoops you could possibly take. So let's actually start building that map with the scoops we just took. Our first scoop gave candidate B 52%. Let's put a bar there. Our second gave them 46%. Bar goes there. The third was 49%. Put a bar there. Now, imagine we did this not 3 times, but thousands, tens of thousands of times. Something pretty amazing starts to happen. And this right here, this is the secret weapon. Even though every single scoop is random, the map of all the possible scoops isn't random at all. They all start to cluster together, and they form this beautiful, predictable shape, a bell curve. And right in the middle of that bell curve, that's where the true answer for the entire population is hiding. This incredible kind of magical idea actually has a name, the central limit theorem. And it's one of the most powerful ideas in all of statistics because it tells us that even within total randomness, there's a hidden, predictable order. We don't need to know the true answer to know what the pattern of all our guesses is going to look like. Okay, so that's the big idea. But how do we actually use this? How does a pollster take their one single poll, their one scoop from the barrel, and turn it into an estimate that we can actually trust? This is how we get from a simple guess to real statistical confidence. The process is actually pretty straightforward. First, you take your one real-world sample. You get your result, your one guess. Let's say it's 52% for candidate A. Then, because you know about that predictable bell curve, you use its shape to build a range of certainty around your guess, a range where the true answer is most likely hiding.
So we have our one result, 52%. But we know it's just one guess out of many possibilities on that bell curve. So the crucial step isn't just to report 52%. It's to use the math of the bell curve to calculate how much uncertainty surrounds that number. And that uncertainty, well, it has a name you've definitely heard before.
It's the margin of error. Let's say it's plus or minus 3%. Now, this is the part almost everyone gets wrong. When you see 95% confidence, it doesn't mean there's a 95% chance that this one poll is exactly right. Nope. It's way more clever. It means that the method we're using to create this range, from 49 to 55, will capture the true population answer 95% of the time. We're confident in our method, which gives us confidence the real answer is in our range. So, is there a way to get more confident? To shrink that range? You bet. You increase your sample size. Think back to our barrel of marbles. Instead of a tiny scoop, what if you used a giant bucket? Your result would be way less random, right? It would be much closer to the true mix. A bigger sample makes that bell curve get taller and skinnier, which shrinks your margin of error and gives you a much more precise estimate. Okay, so this is all super cool for understanding election polls, but honestly, this one big idea, using a small random group to confidently say something about a huge group, it's so much bigger than politics. It's pretty much the foundation of how our modern world works. Seriously, just think about it. How do scientists test a brand new medicine? They can't give it to everyone on the planet. No, they give it to a carefully chosen sample. How do economists figure out the unemployment rate? They don't call every single house. They survey a sample. This method is literally everywhere, underpinning almost all of scientific and social research. And that really brings us to the core of it all, captured perfectly in this quote. Everything we infer, everything we think we know about huge groups, whether it's voters, patients, or the economy, is built on the mathematics of sampling. It's the engine that turns a little bit of data into a whole lot of knowledge. So that impossible question we started with, turns out it's not so impossible after all. It's all about understanding this elegant dance between randomness and predictability. So from now on, when you see a poll, you won't just see a number. You'll see the margin of error, you'll picture that hidden bell curve, and you'll ask the much smarter question. Not, is it wrong, but how confident are they? That's where the real story is.